All right, so this is the last thing that we're going to talk about in chapter number 8, and this all has to do with enthalpies of reaction, which we've actually kind of talked about previously, but we're going to do it in a slightly different, or from a slightly different vantage point. So we know a couple of things kind of conceptually about bond strength. The shorter that the bond is, that means that there's probably 2 or 3 bonds. So a single bond versus a triple bond, well, a single bond is going to be longer than a triple bond. Likewise, the shorter the bond is, the stronger it is. So we can actually use bond strengths as a method to predict an enthalpy for a reaction. So as an example, let's take this reaction right here. What this reaction right here is CBr3H, or HCBr3, and Cl2. And these two components are going to react to form CBr3Cl plus HCl. Okay. Now, what this tells us is we have this molecule right here, one mole of that molecule, 1 mole of this molecule. They react perfectly together to form this molecule and this molecule. Now, when you look at the Lewis structure of this, or the representation that we have right here, the simplistic representation, it's pretty clear what's happening. Well, we're going to be breaking some bonds and we're going to be making some bonds. If you look specifically at the CBr bonds between the reactant and the product, are those bonds still there? Yeah, those bonds remain unchanged. Okay, if you look at the CH bond, however, well, that one's going to change. And in fact, that CH bond is going to be replaced by a CCl bond. Okay, so where is that Cl coming from? Well, that Cl is coming from this molecule of Cl2. So what that means is that we've got to break some bonds and we've got to make some bonds. So if we look at our 2 reactants, we have a total of 2 different bonds that are going to be broken. We also have 2 different bonds that are going to be formed. Okay, so what is the energy that is going to be involved in this overall reaction can be more or less distilled down to what is the energy required to break those bonds and what is the energy involved in making those bonds. So there is a table in your textbook, table 8.4 if you're using the Brown and LeMay textbook, and you can find these bond enthalpies, kind of just do a Google image search or something like that, and you can find the delta H for all of the bonds associated with this specific reaction. Okay, that bond energies, this average bond enthalpies table right here shows approximately what those energies are. So we've got this table. This is specifically showing single bonds, and what we see are, well, what are the bonds that are involved in this CCBr3 and Cl2 molecule, or our reactants and our products? Well, we know that we have a CH bond that is involved, a Cl bond, or a CCl bond that is involved, a HCl bond, and a Cl bond, or a ClCl bond that is going to be involved in all of this. Well, we can kind of take that a step further, or use that information. And we can look at this as, well, our bond enthalpies are always going to be presented as positive numbers. So there are a total of 2 bonds that are being broken. Which bonds are those that are being broken? So from our molecule CBr3H, we know that we're breaking a CH bond. Okay, we are also breaking a Cl-Cl bond. So we can look at those 2 reactants and we can say that we're breaking those 2 bonds. Okay, so the energy associated with a CH bond is 413 kilojoules per mole. The energy associated with breaking a Cl-Cl bond is 242 kilojoules per mole. Okay, so these are endothermic reactions, or these are endothermic processes. Now, at the same time, we are going to be making some bonds. So we have 2 bonds that are being formed. So if we're breaking a CH bond and we're breaking a Cl-Cl bond, well, we are going to make a CCl bond and we're going to make a HCl bond. Again, the units for this are kJ, kilojoules per mole, kJ, oopsies, per mole. Now, ultimately, what that is going to be is we can look at this as the sum of bonds broken plus, now keep in mind that this bonds that are being formed, these are going to be exothermic. So we want to look at those as negative values. So we're going to take the positive values for our bonds that are being broken, our endothermic reactions, plus the negative sum of our bonds being formed. So we are forming one CCl bond. So we're going to add negative 328 to the other bond that is formed, that HCl bond, that is negative 431. Okay, so when we put all of that together, the sum of 413 and 242, that's going to be what, 655 plus negative 328 plus 431. That gives us a grand total of negative 104 kilojoules per mole. So, sorry, just so we can look at that number all together, that's 655 plus negative 759. All right, well, I hope this was helpful, and have a good afternoon. That's the end of chapter number 8, so have a good afternoon.